Okay, so in our last class, so we have studied about the BGP states. Now let's today discuss about our next topic. So let's start with the route injection in the BGP table. So today let's learn how we can inject the routes in a BGP process, right? So the very first one that I mentioned, it is via the network command. Okay, so this is our simple topology. So what I have done is, so this is router R1 and R4, R3. So there is no BGP neighborship between R1 and R4. So we will we will do the neighborship between R1 and R3. R1 is in AS number 200 and R3 is in AS number 100. So we'll make the eBGP neighborship between R1 and R3. These other routers R2, R5, R4. So I just created this topology to demonstrate one more example that we'll discuss later. So let's start with the route injection process. So let me log into R1. So this is R1. So already I have configured the basic IP address. For example, on this interface, the IP address is 14.1. Here we have 14.4. Similarly, between R3 and R4, we have 34.3 here, 34.4 here. Okay. So basic IP configuration I have already done. So what I can mention here is, let's mention this IP address as well, 34.1.1.4, 3. Okay, so here we have 34.1.3 and 34.1.1.4 is here. Okay, so between R3, R4 and R1. So we are running eIGRP with autonomous system number 100. So now let's create the eBGP neighborship between R1 and R3. So if I do a show IP interface brief, so on all my interfaces, I already have the IP addresses. Okay. Serial 3 by 0 I'm not using, so let's, okay, the interface brief. Okay, so let's create the eBGP neighborship between R1 and R3, and we'll use the loopback address. So first let's check the connectivity. My loopback address is 1.1.1, and I want to make the neighborship with R3. So let's first check if I have the route for the R3's loopback. Yes, I do have the loopback IP of R3. I'm learning it via eIGRP because we are running eIGRP between R1, R4, and R3. Let's try to ping if the reachability is fine or not. Because as we have already discussed in our last classes, the very first thing uh, that needs to be there is the reachability, right? So if you want to make the neighborship using the loopback, so first there must be the connectivity or the reachability. So if I do a ping using my loopback because I want to create the neighborship using my loopback, so the connectivity is fine, right? So now we can configure the BGP. What is the AS number that I'm running or I'm going to use here is 200. Router BGP 200 neighbor. Neighbor IP remote AS will be 100, right? So here we'll use AS number 100. Sorry. See, if this is my IP address, right? So mistakenly I have written my IP address. So it is throwing the error. Cannot configure the local system as neighbor, right? I cannot claim myself as a neighbor, right? Neighbor should be somebody else. So neighbor IP remote is 100. update source loopback 0, right? And this point we discussed in our last class also. If I want that always R1 initiate the TCP connection, so in that case, what we can do is we can give one extra command, right? Transport connection mode active, right? And if we want that R3 should never initiate the TCP connection, we can give or we can configure the command passive on R3. That we will do. Okay. Now we already discussed that when the eBGP neighbors are not directly connected, either we need to give eBGP multi-hop, or the second one was the disable connected check. If I go back here, right? So when we are using the update source loopback, that means our eBGP neighbors are not directly connected. So either we need to use the eBGP multi-hop or the disable connected check, right? Okay, so I'll go to R1. I'll give this command, disable connected check. That's it. I'll go to R3, do a undebug show IP interface brief. So I have the loopback 0, and let's see if I have the, because ping is bidirectional and we have already checked the reachability, right? So what AS number I'm going to use is AS number 100 as per the topology. So router BGP 100 neighbor. The neighbor IP will be 1.1.1, right? Remote AS. The neighbor is using 200 AS number. Update source I'll use 0, and I want that R3 should never use or should never initiate the TCP connection. So what command we need to configure here is transport connection mode passive, right? Now what else is left? Because the eBGP neighbor, it is not directly connected, so we also need to give this command. So IBGP summary, it's in idle state. Okay, I go to R1, IBGP. So for TCP, our R1 is the active one, or the what you say, the server, right? So it will initiate the TCP connection. Show TCP break. Okay, it sent the SYN is sent, right? IBGP. Show TCP break. See, R1 is sending the SYN packet, right? But R3 is not responding. What is happening here is if we talk about the indirect neighborship between the eBGP neighbors or the peers. So there, as we discussed a few minutes back, that there are two options. Either we can use, sorry, either we can use disable connected check or eBGP multi-hop. But the problem is with the disable connected check command is that it will work only if the peers are directly connected, right? For example, if there is a connection between R1 and R3, they are directly connected, and we are trying to, uh, we are trying to create the neighborship between R1 and R3 using their loopbacks. So that's why in this scenario, because they are not directly connected, this command is not going to work. If I do do show run section BGP, this command is not going to work. So we need to, what we can do now, we are left with another option, right? I'll remove this command, and what I can do is eBGP multi. I go to R1, show run section router BGP. Let's remove this. Number 333 BGP multi loop, right? Either we can enter or we can give any value. Show TCP group. Now we can see that the TCP connection is established, or also we are getting the log that the neighborship is up now, right? Also, we can verify that in my previous lecture, I already informed, right, that whenever we see 179 in this below this foreign address, it means that this router initiate the TCP connection, right? And it's because we have given the command, or we tell this BGP process that while making any neighborship between this peer, so you should initiate the connection. And for R3 we have mentioned the passive keyword, so R3 will never initiate the TCP connection. So now our neighborship is up, right? So now let's see how we can inject the networks, right, in BGP. So if you see here, show IP BGP, this is the command to check what are the routes in the BGP table. Or here in this command, show IP BGP summary, you can see what are the routes received from this particular neighbor, right? So show IP BGP summary, this command will tell us the output from the neighbor. What is the neighbor IP address, in which AS number the neighbor lies, and if the what is the status of the of our neighborship, it's up or down, or for how long it's been up, right? How many routes we have been receiving from the neighbor. Okay, so if I go back to R3, let's say, let's create some loopback. Show IP interface brief. So I'm creating one loopback. Let's say loopback 10, IP address 10.10.10.10 255.255.255.0. Okay. By default, BGP is not going to take any action. So our first option is we how to inject the route via network command. So how I can do it? Router BGP 100 10.10.10, and now I need to specify what is the mask for that particular subnet, right? So what mask we have configured is 255.255.0. Okay, and we need to make sure that whatever the mask is in the routing table, we must configure that one. Otherwise, this particular subnet is not going to make it into the BGP table. Okay, for example, let's say BGP incorrect network or mask, right? Let's say I do like this, mask 255.255. Okay, show run section router BGP. So what I have done is I give the network command and the subnet 10.10.0.0 mask and the subnet mask /16. But in our routing table, or you can say our loopback, it's not /16, but it's /24. So if I go to show IP BGP and check if this route is in BGP table or not, You can see there is nothing in the BGP table. Why? Because whenever we give this command, so our router is going to check with the BGP process, and BGP process is going to look into the routing table. Okay, let's check if we have this route in routing table. IP route. We have the route in the routing table, right? But it is having the subnet mask of /24. But what we have configured is /16. So the mask, until and unless we configure the correct mask, this subnet is not going to make into the BGP table, and until and unless it is in the BGP table, it is not going to advertise this to the neighbor, right? Here you can see that there is nothing. The prefix received 0. So IPBGP. Okay. So we need to configure the proper subnet mask. Okay. Router BGP 100. You can say no. Let's say this one. Let's remove this. So we need to configure the proper subnet mask. Otherwise, it is not going to install it into the BGP table. So now we put the network ID and the proper mask, right? If I go to show IP BGP, now we can see that a route is in BGP table, right? So you can see the star. There are two symbols. One is star. Star means this route is valid, and this greater than sign, this is the best. And we need to remember that whenever there is anything in the BGP table, it must be valid and best. Only then it will share this route or advertise this route to its neighbor, BGP neighbor. Okay, so now if I go to R1, we can see that we are receiving this route. Okay. Next, for example, let's create another loopback. Interface loopback 11.1.1.1 255.0.0.0. Show IP route. So I have this 11 route, right? I have this 11 route, right, in my routing table. So now, because this is a class A subnet, right? This is a class A subnet, right? 11.1.1.1. Show run interface loopback 11. So this is a class A subnet, and this is the default subnet mask, right? We have the default subnet mask for each class. Class A we have /8, class B we have /16, class C we have /24. So now in this case, if I go to router BGP process, and if I want to advertise this subnet, so I don't need to mention the mask, because in the routing table also this is the with the default subnet mask. Okay, so if I just click enter, IPBGP summary, IPBGP, you see. So if there is any route which belongs to a particular class and it is having the default subnet mask, so you do not need to mention the mask in this network command. Okay. So let's take another example. If I say interface loopback 172, IP address 172.16.16.100 255.255.255.0. Okay. Show interface loopback 172. 172 is a slash. I mean, 172 is a class B subnet, right? Class B IP. This is a class B IP address. Just forget this. By default, the subnet mask will be /16, but what we have taken here, it's /24. So now this time If I just write like this 172.16.0.0 and enter, it is not going to work. IPBGP. Why? Because if we are just typing this and we are not using the mask mask in this command, and we are just saying the network ID and enter, so by default it will consider it as a /16 because this is a class B subnet, and it will check it in its routing table. Okay, yes, we have the subnet, but it is not it is not /16, it is /24, right? So it is not going to install it. So we need to make sure if we are just entering without this mask keyword, so we need to make sure that that particular subnet belongs to a particular class, and it is having the default subnet mask in the routing table. Only then it will affect. Otherwise, if it is let's say it is a class A subnet and in the routing table it is having the class B or C / subnet mask, then you must use the keyword mask. Okay. Okay. Else using static null root plus network command. Yes. Let's open paint. What we can do is, let's suppose I have R1 and this is R2. Okay. So they are the BGP neighbors. Let's suppose behind R1 there are thousands of subnets, right? 172.16.16 something. Okay, you have thousands of subnets, and you want to you don't want to advertise all of them, but you want to advertise some summary or something, right? So that if R2 wants to communicate to any of these subnet, he can just use that summary route and he can reach to R1, and then the communication can happen, right? So in that case, what we can do is, and in live network also you'll find a lot of configuration like this. So let's say what I can do is, I have a route 250, let's say 70.70. I'll create a static null route. Okay, I'm assuming that behind R3 there are a lot of subnet belongs to this 70. Okay, so I'll create one null route. Okay, and what I will do is, I'll go to the router BGP process. I can do two things. Either I can redistribute this like this, redistribute static. Okay, I do a show IP BGP. You can see now this is advertised as a static route. Otherwise, what I can do is, I can just put a network statement 0, not 772, it's 70.70, 0.0, mask 255, 2550.0. BGP. Okay. So now you can see it is in the BGP table, and also it is advertising our R1. Oh, not now. Let's wait. Because BGP is a bit slow. So if what we can do is we can refresh the updates. So what I can do is clear IP BGP star soft out. So I'll again advertise whatever the routes are on my BGP table. I will advertise to my neighbor. So now if I go to R1, you can see, right? Because BGP is a slow protocol, right? So it takes some time. So if in live network also, if you have done some changes in BGP, so you need to make sure that you have clear the updates. So you can clear the updates Because if I'm giving this command clear IP BGP star soft out, let's suppose I am having neighborship with my 5 peers. Okay, let's say R3 is having neighborship with R1, R2, R3, R4, R5. So it is going to refresh updates for refresh the outgoing updates for all neighbors. If I want to do it only for a particular neighbor, and that's the ideal case, right? So in live network, also in the operations, what we need to do is if I need to clear the updates for one particular neighbor, what I will do is clear IP BGP. I will mention the neighbor IP and I will say soft. I can mention both direction. If I just say soft and enter, okay, it will refresh the incoming and outgoing updates both. If I want to refresh the updates in one direction only, then I can specify the direction. Either I can say in, so it will refresh the incoming updates, whatever it is receiving from 1.1.1, it will request the router to send back the updates again. Okay. If I just I'm saying the out, it means that whatever I'm sending to 1.1.1, I'll resend it with the new policy that is implemented on me. Okay. Show IP BGP summary. Show IP BGP. Okay. Next, next what we need to check is redistribution. We have already checked. So we have checked that we can do the redistribute static command, and if you want to redistribute the loopback, you can say redistribute connected. Use of auto-summary. Yes. So now let's see how this auto-summary is working in BGP, because we have seen auto-summary in eBGP also. So let's see how the auto-summary is working in the BGP. So let's say show IP interface brief. I'm creating one loopback here. Let's go back to R3 because we are doing all the testing here. So let's create one more loopback. Let's say interface loopback. I created 13.13. Let's say 13.1.1.1 552552550. Sorry, interface loopback 13. IP address 13.1.1.1. Okay, 13 I'm already using, so let's say 33. Okay, so this is a class A IP address, right? But what we are using /24. So if I want to advertise this subnet, and if I go to router BGP process, and if I just say network 33.0.0.0, right? Or just say like this. If I check show IP BGP, so it is not going to advertise this subnet. Why? Because this is a class A IP address, right? Because and as we have already verified that if we are entering without that mask keyword, it is going to check it into its routing table. It will find this, but in the routing table it is /24, so it is not going to install it. So to overcome this process, because in BGP we can have different kind of requirements, and for each and every requirement that we can think of, there is a solution in BGP. So let's say if you have thousands of routes in your BGP table, right? And you don't want to care about like if you are using this mask keyword or not, and you just want to advertise the routes and you want to bypass this condition. So right now the loopback that we have created, it is not advertised because we are not using the proper mask in right under the BGP process. So to bypass this condition, what we can do is we can enable the auto summary. Now auto summary is on. Once this auto summary is on, So what the BGP process will check is it will go to the routing table. You just mentioned 33. It will check, okay, I have something here in this routing table with 33. Okay, no problem. I will advertise it. You see, it is advertised. And if you want to check what I am advertising to my neighbor, show IP BGP summary. In BGP, what I can do is show IP. I will type show IP BGP neighbors, neighbor IP, and I will give this command advertise routes. So these are the total number of prefixes 5 that I am advertising. So the new subnet, it is also advertising, right? 33. So if I go to R1, show IP BGP summary. Show IP BGP, so it is receiving the 33 subnet. So we can also check what we are receiving from our neighbor. Show IP BGP neighbor. Okay. So via this command, we can also check what are the routes we are receiving from our neighbor. Okay. Okay, what else? IBGP learn routes redistribution to IGP. So this one, we need to make sure that you see the very first line. By default, IBGP learned routes are not advertised to uh, IGP to avoid the routing loops. So what does it means? So for this case, I have created this topology. So just let me brief what exactly it is. So between R1, R4, R3, we are running the eIGRP. Okay. Between R1 and R3, it's eBGP. As we have already configured, R3 is in AS100, R2 is R1 is in AS200. So R2 will be in AS200. So here they will be IBGP neighbor. Okay. R2 and R5 will create OSPF. So R2 and R5 will be OSPF neighbor, or you can say they will be IGP, right? And same between R4 and R5, we will run OSPF. So if I go to R2, so I think it will be more clear if, if we are doing the practical rather than just reading the theory. So what the theory is saying, so by default, if I'm learning any IBGP route, right? If I'm learning any route from my IBGP neighbor, by default, I'm not going to advertise these routes into any IGP, right? For example, let's say R3 advertise something to R1 because they are eBGP neighbor. So R1 will advertise to IBGP neighbor to R2, right? R3 will advertise to R1, R1 will advertise to R2. Let's say there is a OSPF neighborship between R2 and R5, and we are redistributing the BGP into OSPF. So by default, because R2 learn these routes from R1, it is not going to advertise to R5. So why it is doing so? Why this feature? So let's let's see a quick practical for this. Uh, let's see what I configured by default. So IP interface brief. So I have just done the basic configuration on the interfaces, right? So 12.2, 25.2, and G loopback. So on on R2, let's create the BGP. So router BGP 200, because there needs to be the IBGP neighbor. Okay, let's form the neighborship via the directly connected interface only. So remote AS will be 200. Okay. And I go to R1, router BGP 200, neighbor IP is 12.1.1.2, right? We can check. So CDP neighbor entry. So CDP entry start protocol. By this command, we can check what is the IP address configured on our neighbor without logging to them. Okay. So on R2, on my connected interface, what is the IP address? 12.2. So neighbor IP remote is 200. So IBGP summary. Let's wait. It will come up. Here the reachability. Let's check. Yes. So the neighborship is now. Okay. And now let's create the OSPF between R2 and R5. So if I go to R2 interface serial 3 by 1, I will say IP OSPF 1 area 0. Okay. I will go to R5. On serial 3 by 1, I will say IP OSPF 1 area 0. We will also enable the OSPF on the link going to another router R4. So serial 3 by 0, I will run the same command. So on R2, on this interface also, we will just create or will enable the OSPF. Interface serial 3 by 0, I will say IP OSPF 1 area 0. OSPF, what is it is saying? OSPF will not operate on this interface until IP is configured. I think IP address is not configured here. Oh, sorry. We are on R2. It's R4 actually. Okay, so it's interface serial 3 by 0. Shut. IP OSPF 1 area 0. IP OSPF interface brief. IP OSPF neighbor. Okay, so we have the full neighborship. So now let's review it again. So between R1 and R3 we have eBGP neighborship. R1, R4 and R3 are also having the eIGRP neighborship. Between R1 and R2 we have IBGP. R2 and R5 we have OSPF, and R4 and R5 also we have OSPF. So now let's say IPBGP web interface brief. I have one loopback 100. Okay, show run interface loopback 100. So here we have the loopback 100 with /24. Let's say I'm advertising it in eIGRP. So router eIGRP 100 network 100. So IP eIGRP interfaces. So now we are also running eIGRP on this loopback. So it will be advertised to eIGRP neighbors. So if I go to R1 and if I say show IP route eIGRP. Okay, let's do one thing. R3. Let's redistribute it actually. Redistribute. Connected. I think to demonstrate this, I will go with the let's do like this. I'll put one null route. Okay. And what I will do is I will go to router eIGRP 100, redistribute, static, metric. Done. So now what I have done is show run section router eIGRP. So I'm running eIGRP and I have redistributed the static route. Okay, what is the static route? Show IP route static IP. So we have created one null route. Okay, 100.100.100.0/24, and we are advertising it into eIGRP. So if I go here, show IP route. We are not getting it. We are getting 50. Okay. This loop 100. Let's show IP interface brief. Let's say because we have already put the route to null 0, or let's say let's keep it like this. Route IGRP route IGRP. It is not receiving it. Let's go to R4. Route. Route. So it is not receiving. Let's see what is happening at R3. Show run section GRP. So we have distribute the static. Also we are doing the route. The route. Okay. It is installing it as a connected route. Okay. Okay, so if I go to R1, I can see we have this route which we have advertised into eIGRP, right? From R3. IP route eIGRP. Okay. Show IP route. So now R1 is getting this route via eIGRP, right? And same R, if I go to R4 and if I say show IP route, it is getting this route via eIGRP external, right? As a eIGRP external, because we are redistributing it. So now if I check on R2, if I go to R2, because R1 and R2 are having the BGP neighborship, right? I check show IP BGP. So let's advertise this. If I go to R3, let's advertise this subnet into BGP also. If I go to router BGP, what is the AS number? We have 100. I say network 100.100.100.0, mask 255.255.255.0, show IP BGP. So now we can see that we are also advertising it to our BGP neighbor. So if I go to show IP BGP neighbor, I check advertise routes. So I'm advertising it to R1, right? And R1 is show IP BGP something. R1 is advertising it to R2 also, right? 100.100.0. Now, by default, what is our rule? So if I redistribute this BGP into OSPF, it is not going to work. because of the loop avoidance mechanism. And why it is happening, if I go to R2 and let's say I say router OSPF 1 redistribute BGP, what is the AS number 200, right? And say subnets, so that the classless subnets are also advertised, right? Okay. So ideally, if I check show IPBGP here, so ideally R2 should advertise this subnet, these subnets to R5, because we are redistributing the BGP into OSPF, right? If I go here, show run section about OSPF. So we are redistributing BGP, right, into OSPF. So if I go and check on R5, if I'm receiving any route into OSPF or not, show IP route OSPF. I'm not receiving anything, right? Why? Because by default, there is IBGP neighborship between R1 and R2, and just because the rule how BGP is designed, if I'm learning anything from my IBGP neighbor, I'm not going to advertise it into IGP because OSPF is an IGP, right? So how we can tell R2 that okay, you have to advertise the IBGP LAN route into OSPF? We need to give one command. So if I go to router BGP process and I will say BGP redistribute internally, right? It means you need to you can redistribute, or I'm allowing you to redistribute the IBGP LAN routes into IGP. Okay. Sometime, I mean, not sometime. I think we need to think about our architecture first. Only then this command will work. Because if I go to R5, oh, now it's working, so it's fine. Sometime what happens here is if you are giving this command BGP redistribute internal, it is not going to work at once. So you need to break the neighborship and create it again. Only then it will redistribute the routes. But maybe because it's no, it's the GNS, that's why it is. But I never tried it into line network. So okay, so let's see. Show IP route to SPF. Now I'm learning the routes, right? And also I have learned this subnet, right? 100.100.0. Now you see R, if I go to R4, show IP route. Earlier R4 was learning this route via eIGRP, right? Via here. But now it started learning it via OSPF because the OSPF has the lower AD value 110, and R4 was receiving this route via eIGRP, and eIGRP redistributed routes, right? And eIGRP redistribute routes are having the AD value of 170. So that's why R4 dropped that um, route and install the new one, right? Because if I just shut this port, which is going to R5, if I say serial 3 by 0 shut, now OSPF will be down, right? And now it will start receiving this route. You see, now it is receiving the 100.100.0 route via eIGRP, and the AD is 170, right? Because now we don't have the OSPF, we have shut the link. Show IP OSPF neighbor, nothing is there. Let's make it up again. OSPF is back. Show IP route. Now again it installed the route from OSPF. Okay. Now see this 100.100.100. something. This route is at R4 also, R1 also, R2 and R5, right? So if I try to let's suppose there is some subnet or some IP address in this subnet behind R1 or R3, and I try to access it from R4. Let's see what happens. I do a trace, let's say 100.100.100.100 using my source loopback. Let's see what happens. It is sending it to R1, packet is going to R4, 2, 1, 4. It is just looping, right? It is going like this. So now there is a potential loop, right? So to avoid this kind of situation, so BGP is designed like this. So we need to make sure there is no redundant links, and we need to know, right? Like if there is no looping between our IGP. So just in case we advertise the IBGP into our IGPs, it is not going to create any loop, right? So to avoid this kind of situation, so this condition was created in BGP. So by default, IBGP LAN routes are not advertised to IGP. So this command that we have enabled, after which R2 started, bypassing this condition. So it is for the cases like suppose we don't have anything here, right? There is no neighborship. And now if R3 is advertising something to R1, I mean, let's say there is no link here. So if R1 is advertising something to R2, now if R2 does not redistribute the IBGP learned route into OSPF, then R4, R5 will never learn about these 100.100.100.0/24 routes, right? So in that type of cases, it will be mandatory for us to run this command so that these IBGP learn routes can be advertised to IGP. But by default, they are disabled. Okay, you cannot redistribute the IBGP learn route into IGPs, just to avoid these kind of loops that we have seen in this, right? So because it is looping, R4 is sending to R5, R5 to R2, R2 to R1, R1 to R4, and because R4 is learning install the OSPF routes via R5 instead of the CIGRP, so it is just looping back and forth. Okay. Okay, so the next one is the BGP backdoor command. So we'll do it in next class.